Hello, everyone. We're excited to have you participate with our very first installment of the Utility Cloud Skills Series, specifically focusing this time on unidirectional hydrant flushing. I'd like to introduce myself. My name is Catherine Mingle. I'm the Vice President of Operations here at Utility Cloud, and I will be acting today as your moderator. Before we jump into our content, I'd like to cover a couple of housekeeping items. So first, as typical of webinars you may have participated in, we've placed all our attendees on mute today. This is to eliminate background noise or distraction during our program, and I will also ask that our presenters mute themselves when they're not speaking. Second, in order to ensure that we can stay on time with our program, we'll ask you to pose any questions that you have in our chat window. I will be monitoring the chat and will ensure that your questions get addressed either during our program, at the end when we are recapping our content, or after we adjourn in our Q&A document that we will be sending out to you via email should we run out of time. We're very privileged to have several experts on our webinar panel today, so you will notice that we will be facilitating this session in a very conversational manner. We feel that this will add additional value for you. Now, without further ado, I'd love to introduce our panelists to you. So first, our team from Utility Cloud. I'm pleased to introduce Ms. Amber Buckhan. She's our Senior Manager of Customer Success. We also have on the panel Dan Colano, our CEO. And last but not least, Mark Moreau, our Founder and Chief Revenue Officer. For those who aren't familiar with our company, Utility Cloud, really briefly about us, we're a compliance, operations, and asset management platform that enables utilities to manage, maintain, and report on their physical assets. We were built specifically for the waters industry's most complex challenges, including UDF, which we're going to cover today. We also have someone from Unilink joining us, Derek McLaren. He's the Director of Design and Strategy. Unilink is a state-of-the-art cloud-based utility billing and customer information system that is specifically designed for water, wastewater, and stormwater. They offer real-time integrations built in for several accounting applications, all major meter reading systems, and even our Utility Cloud asset management platform. They also offer municipal website and customer communication engines that allows municipal organizations to extend their presence to the web and social media to communicate with their customers and manage public notifications. You're going to learn more about that during our webinar today. And last but certainly not least, from Hose Monster, we have Michael Anderson, their sales manager. Hose Monster is an industry-leading company dedicated to providing equipment, software, and procedural solutions that make the jobs of maintaining water distribution systems and pump testing safe, accurate, and simple. Welcome, everyone. We're thrilled to have you on today. All right, moving forward. To get us kicked off, why are you here and what are you going to learn from us? So we're going to cover several topics. Probably most importantly, why implement a UDF program? We're going to go over the business case and benefits. We're going to give you a 5-step program on how to get started. We're going to cover the resources that you can use to execute this program. And at the very end, we're going to go in depth on 5 tangible takeaway tools that we'll be providing to you to help you stand up or even improve your existing program. So with that, I'm going to turn this program over to Amber. Amber, take us away.
Thank you, Catherine. Good afternoon, everyone. We are excited to be jumping into our skill series session for today. So we're going to kick off with why. Why choose to do unidirectional flushing? Before we jump into the why, it's best to understand the types of flushing that we have that our systems use and the different methodology behind those. In talking with Dan, he actually has some really good insight on the differences between conventional versus UDF. Dan, can you shed a little bit more light on these 2 items?
Yeah, of course. So guys, just real brief. So look, every pipe in America has some degree of chemical scaling and biofilms inside of it, and the water that we utilize and drink passes through this and interacts with it. So UDF, I guess the main point here is that conventional hydrant flushing, the mechanism by which flushing happens from all direction and pulls from multiple segments of pipe, is a good way to clear out the water, which is more of the symptom. However, if you want to address the root cause, which is really the chemical scaling and biofilm on the pipe, UDF enables you to generate velocity. So the name of the game here is really velocity of the water, and we'll get into the details of that. But in short, sort of isolating that segment of pipe and getting that velocity up to a certain level really enables you to really clean out the pipes. So that's the core difference. I'm sure people are fairly familiar with that. But here in the diagram, you obviously see what that looks like and how you achieve that through closing valves. Of course, we'll get into a lot more detail in the presentation here.
Absolutely. Thank you, Dan. And looking at some of, the reasons why we use UDF and some of those benefits, there are 4 key benefits that we have identified to implementing an effective UDF program. Those benefits can include water quality improvements, water efficiency, we notice as well. Also, asset management and capital planning and knowledge transfer. Those are the 4 key benefits. Mark and I have really had some great conversations around these benefits. Mark, can you go into detail a little bit about each of these benefits and how it could apply to UDF?
Sure, Amber, thanks, and hello, everyone. Yeah, the main reason you do it is really water quality, right? So the idea is to reduce the contaminants in that pipe that under normal velocities kind of sit there and build up over time. And getting rid of that biofilm is a key contributing factor to deteriorating your chlorine residual over time, as well as increased turbidity and water color issues. And so that water quality really is the main driver, but it's like Dan had mentioned earlier, the real purpose there is to eliminate the contributing factors to poor water quality. And a lot of utilities invest lots of money into state-of-the-art treatment facilities that put out beautiful water, but then goes into a distribution system that then contaminates it a bit. So this really, if you do a good UDF program, it will help water quality tremendously, including other objectives around water quality like lead and copper reduction and other things. So this has a wide range of benefits across all of the water quality thresholds that we monitor in the distribution system. Water efficiency gets greatly improved as well, because you get the debris out of that pipe. You're able to improve your roughness coefficients and ultimately create better and more capacity fire flows. More, get back to what the system was designed to do if there are any obstructions in there. And finally, in the water efficiency area, you use less water. So you're not just generically dumping water on the ground. You're focusing that stream to get a targeted velocity until you reach a desired turbidity level in that segment of line. And doing that using EDF is up to 40% less water usage to do that. And through the exercise itself, you can really leverage the exercise to gather asset management information and achieve other regulatory compliance objectives, as well as gather KPIs and benchmarking data to show improvement over the years. And finally, knowledge transfer. Documenting your UDF program. The first time you do it, and maybe you hire a consultant to help you, generate the UDF plan, but you may generate that plan and find that it's not matching what is expected. The real world circumstances aren't matching what's expected. And you may find conditions that in the system that may not be the same as what you have documented. So not transferring the knowledge from people who really know the system and really know the details of it into that program help captures that knowledge and pass it down through the generations.
And Mark, I'm just going
Absolutely.
to add a couple thoughts there. So that was totally, I mean, I think one overarching comment here is that UDF is sort of the ultimate kill a couple birds with one stone here. So, I mean, think of it, just the value of the assets sort of that sit underground. Through some research, I think it's probably around 60 or 70% of your total capex is sitting underground. And so first of all, doing UDF is a critical like preventive maintenance activity. But also while you're going through this process, I mean, the number of valves and hydrants that you're exercising, and then similarly collecting key information that, again, as Mark described, is a discrepancy with any models or asset management systems, can really expose issues, whether you have like water loss happening or you have blockages or any type of issues like that. So you're really kind of checking a lot of boxes while going through this one exercise. And then just really practically, I mean, the accomplishing, when you get that velocity going and you're scouring your pipes, it's quite affordable compared to your alternatives. So if you think about, pigging the pipes or pumping some enzymes through your pipes, both of those options, or of course the alternative of doing nothing and risking water quality issues, those are typically much more expensive ways of addressing the same problem. So super, super powerful in terms of asset management.
Absolutely. Thank you, Mark and Dan. One of my biggest takeaways myself, especially with working a lot of the clients that I have, is the knowledge transfer. I hear several times of how much of a benefit it is to be able to put this information in a platform that can grow and scale and be passed on from generations. All of us eventually want to retire one day, and this is a great way to be able to find that information and store it. So definitely some really great key benefits there. Now that we've looked at some of the benefits to implementing a UDF plan, let's get kind of down into the details of how do we implement that plan. So we've talked about the why. Let's bring into the how. So our team is going to take you through a journey of 5 steps on how to effectively plan, map, and build out your UDF plan. So we're going to talk about consolidating your assets. We're going to dive into how to conduct criticality assessments on those and condition assessments. We'll talk about best practices for creating that deflushing plan. And then how do you execute it? So we'll migrate into the execution of your plan. And then what do you do once you've made it through these processes? We want to look at what assessing the data looks like and practices for refining it to make it even better in years moving forward. And what's important to identify here is everybody that's joined, you're all in different stages of implementing your UDF program, whether you haven't yet started one, or you use conventional flushing, or you're just now getting ready to dive into UDF system with plans that your engineer has drafted for you. There's valuable points to each and every step here that can apply to any part of the journey that you're on. So as we look at and migrate into step 1, the first thing is you want to consolidate your assets. You want to work to pull any GIS mapping or hydraulic models that you have, any as-built, any trivial knowledge that can help contribute to the asset information to help you kind of bring everything into one sector to be evaluated. Ways that you can do that. It's nice to be able to leverage a platform to help you be able to migrate that data and then combine asset attributes, any fields that may be pertinent. All of that will be used for when you do your criticality condition assessments on those assets. And that actually leads you directly in to step 2. So first step is to do your homework and get everything consolidated. The second step is to survey those assets. And Mark is going to take us through what that journey looks like on surveying your assets, your valves, hydrants, and water mains.
Thanks, Amber. Yeah, once you have your data sources kind of consolidated into one place, it's a good idea to kind of collate that all together. And really what you have to do is put it in a format that allows you to go out and survey your assets that make up the distribution system there. And so what you want to do is make sure you've gathered the mapping information and other information that you might have, whatever form it's in, and develop a plan to go out and check them, for readiness. Basically, you want to make sure that they're ready to be exercised according to a plan that you'll develop after this. and you know, the key things you want to do during that survey activity is really confirm your spatial assumptions. So, you know, anything that is not where you think it is, correcting that information. So going back to your GIS system or other asset system of record and making sure that that data is correct. And also identifying any missing information, so segments of pipe or hydrants or valves that may not be documented are important to make sure that they are documented. And really confirm asset attributes as well while you're out there. So you want to confirm that the sizes are what you think they are, you know, the makes and models of the equipment is there. So you're just confirming that, you know, the size of the infrastructure is also what you think it is. and you're then, you know, after you've confirmed the data, while you're confirming the data, you're going to exercise this equipment too, or at least make sure that it's ready to be exercised. So for valves, you want to make sure they're not paved over or inaccessible, and same for hydrants. You want to make sure that there's not vegetation overgrowth or other obstructions that would prevent you from exercising that equipment. And you know, if you can exercise that equipment as well, so make sure that the valves can turn to the expected number of turns, and make sure the hydrants can be exercised. Now, if you have valve exercise programs in place or hydrant, you know, inspection programs in place, then you know that's probably less laborsome. But you know, everybody has a different starting point here, so just wanted to cover that real quick. A couple other things you want to do while you're out there. You know, why not take advantage of the time to collect some additional metadata? It's not super time consuming, but, you know, to be able to collect information that contribute to asset management objectives and ultimately leading to better capital planning and other preventive maintenance activities. So, you know, why not collect that condition information and, you know, understand what needs to be repaired where. So, you know, first order of business, find what's not working and get that fixed. But second, you know, do a condition assessment and collect data that contributes to criticality and risk while you're out there. And so when you come back and after your flushing program is over, you can run some quick reports and understand where you should be spending money next in the infrastructure. So it's a great opportunity to kind of kill two birds with one stone, if you will. A couple other things you'll do while you're out there is just generally observe the area. You may want to take a look at things like catch basins and how clean they are, or if you have a catch basin cleaning program in place, great. But if you don't, and you know, CMOM is early at your facilities, and you know, you want to make sure that any runoff you produce from this hydrant flushing will have a place to go, and there's clean runs to do that. And you also want to note you know, the traffic patterns in the areas, and as well as the time of day that you plan to flush, because there's all these considerations. And later on, we'll provide you some resources to understand what tools you should have and how you mitigate flooding and how you divert the water and so on. But generally, you know, the point here is collect the information, make sure that it's ready, exercise it to ensure it's ready, and then also at the same time collect the asset management information to inform your future capital planning around those types of assets. We're going to give you guys in the tool pack an asset management data collection form. So this workbook you can fill out using Excel or other tabular program to not only assess the condition, but collect that asset management information and also assess readiness. So one last point on this is you want to make sure that every asset that you're assessing on your maps are uniquely identified. So you want to make sure your hydrants and valves are all uniquely identified, and it's easy to do that. You simply can prefix an ID with HYD for hydrant and then dash a unique number, or if you've already got a unique number scheme, then you can just run with that. But it's important because later when you give this information to an engineer or qualified flushing designer, they're going to reference those IDs, and ultimately you'll need to know which valves or what IDs in order to exercise according to the plan. Dan, did I miss anything?
Thank you.
Yeah, Mark, I think you hit it all. Yeah, again, just for you guys, I think one thing to keep in mind, this is, as Mark said, this is one template that we'll share with you guys. Just generally, as we're going through this too, we've consolidated all these steps into a fairly detailed checklist. So feel free to take notes, of course, but we want to make sure that you know that some more information is coming after this as well.
Awesome. So as we finish up the criticality and condition assessments and really survey those assets, that's going to transition us to creating the flushing plan. So what this looks like is once you've done the groundwork on pulling together all of your asset information, surveying those assets, finding any troubled areas and looking to resolve those, that's when you're going to take all of the data that you've collected and everything that you've compiled, and you're going to work with either an engineering firm or a qualified professional to help create your flushing plan. Dan, can you kind of go through the steps of what might be valuable to our audience when creating a flushing plan and the considerations they might want to look at when getting ready to approach this step?
Yeah, of course. So as Amber said, this can be a place where you engage an engineering firm, though it isn't required. So I'm going to speak sort of agnostic to which route you take for a minute. This is all about defining your zones and your sequences. So a zone is an area, and your sequences are basically the loops that you're going to design. That should kind of roughly equate to typically kind of precisely equate to one working day worth of work. I mean, in general, you want to consider closing those loops within the day's work. And this is also the point where you may or may not want to be using a hydraulic model. So the hydraulic model will help you predict what sort of velocities you can hit based on opening and closing of different valves across your zones and sequences. So that, again, you don't have to go that route. There are, I'm sure in many utilities, there are folks who just really know the network very well. So there are options here. I think a couple things that just good golden rules of thumb that we're going to try and highlight here. One is, and we'll go into this in a little bit more detail on the next slide too, is you want to think about your velocity at 5 feet per second being somewhat optimal. Above 7 feet per second, you start to enter the risk territory of main break. That's probably too much velocity, and at the, let's call it 2 or 3 feet per second, you're not scouring. So when you think about the velocity that you need to achieve, that's what you need. That's in order. If your goal is to scour your pipes, that's what you need to be hitting. I'm not going to go to the next slide yet, but we will talk about how you can understand your velocities. So again, I think just some good rules of thumb here, regardless of which path you take to defining your zones and sequences. One is really thinking about starting at the source and working outwards from that point. And just as a principle of designing the UDF program. And then second one is that as far as sort of linking your sequences, apologies if this is obvious, but you do want to be sort of pulling from, you want to be pulling from clean water segments, if that makes sense. So each segment you want to be already flushed and reaching sort of one that's already passed your turbidity tests and is already cleared. So you really want to think about starting at that source and going outward. Again, that's an area where an engineering firm would be helpful in designing that. On the output of that, though, what you're going to end up with, whether you go through the engineering firm or not, or hydraulic model or not, you're going to end up with your zones and sequences. Like, that's the output. So I don't want to get too far ahead of the cart before the horse here, but we will talk about now what do you do with that information. That's the information that you're going to action to implement. Amber, if we can go to the next slide for 2 seconds. So this is, and I want Mark to chime in here too, but speaking of velocities, actually, Mark, do you mind kicking off the velocity piece?
Yeah, no worries, totally. So the velocity, like Dan said, you really want to hit that 5 foot per second velocity. And, you know, typically when you're flushing these segments, you're going to be measuring flow, right? So you need a quick way to kind of understand what the target flow rate would be given the size of the pipe and the target velocity. So this is a handy chart that you can use to you know, find your target flow rate for the given main size. So for example, if we took you know, a 6-inch main size and we were targeting 5 feet per second, you want to be targeting between 360 and 720. You want to just kind of, you want to get right in the middle there. And you know, the reason we don't strictly define 5 foot per second here is just because, you know, it's going to be really hard to dial that in. We saw a good tip from some guys in the field where they actually put a gate valve between the hydrant and the measurement device for the flow. And what that allowed them to do was 2 things. And this is like an insider tip. What you put the gate valve on and then you open the hydrant and you leave the gate valve closed. And that eliminates what they call hydrant pop, which the gate where the seal may stick, where you're freewheeling the valve on the hydrant and then it pops open. And what happens in that case, it creates a water hammer effect, which could cause you some problems in main breaks. And so putting that gate valve in front of the measurement device allows you to fully open the hydrant and let it fill the barrel and not have that hammer effect. And then you can have better control on the flow using the small gate valve. So pretty cool idea, but it lets you dial into this gallons per minute, which will get you to the velocity that you're trying to target to really scour that pipe that you're targeting there. So the time that you do it is sometimes recommended by whoever authored the study, but mainly you're looking to get below 1 NTU on the turbidity. So the NTU values is when you're flushing, if you're measuring and you're getting down to 1, then it's a good time to stop flushing. But there's usually going to be a minimum time. So if they say, hey, your minimum time is 20 minutes, or whoever designed the flushing program thinks that you should do it for a minimum of 20 minutes, then it's 20 minutes or 1, you know, at 1 NTU after that is what you want to kind of watch for. So, but you know, you want to use a turbidity meter. You don't want to do the white cup test or the white sheet test. I mean, that'll work generally, but you really want to get a turbidity meter and do that bench test at the time. But you know, really the velocity is what matters. And you know, it could take 20 minutes. It could take 3 hours. So be prepared. Make sure there's runoff. Make sure you have traffic control, and just be aware that it could take longer than what the plan says, especially if you're just starting doing UDF programs. You make sure your system is full, you know, and you know, make sure that you're not doing it during high traffic periods or rush hour so on the main artery page sites. So Dan, you know, I guess I elaborate a little bit there. There's probably more to add.
Yeah, no, that's you pretty much hit it all. I think a couple data points to highlight in addition to that is take this with a grain of salt, kind of directional advice here, but if just again looking at some data that we consolidated per 100 miles of main, you can roughly think of that as 500 sequences and about 15 million gallons of total flushed water. That's going to depend dramatically on your system. And then thinking about per flush, how many gallons you're expected to push out. Again, just rule of thumb, 20,000. As Mark said, that can vary dramatically based on a number of factors. But yeah, no, that was great. And we'll also get into, I think, some of the other practical advice for as you're preparing, like what kind of equipment you want to have, like making sure you got your tarps prepared, what for those long flushes, what kind of things you want to consider. So no, really good. Let's awesome. That was great. Let's keep moving, Amber.
That was great. I did have one addition that I wanted to touch on too. So when doing your assessment, and I'm going to retract a slide back, when you're doing your assessment, is there anything, we want to make sure that we're coordinating certain follow-up items or post-plan reviews with our engineers. I know we've notated that, Dan or Mark, is there anything else that we should be coordinating with our engineers on besides a post-assessment review of the UDF? or dechlorination requirements from runoff?
Amber, yeah, there's a really good tip is if you're engaged, a model and an engineer using a hydraulic model to come up with the UDF, make sure that you ask them, in the initial scope of work to have a follow-up. So include in that project, after the first time you execute that plan, a way to feed back the data and have them assess that information. That's one area, and I'll talk a little bit more deeply on that in a second. But the other area is dechlorination. That's something not a lot of people think about, but if you're running off into a body of water that's a fishery or other environmentally protected area, you want to make sure that you ask them to evaluate that throughout the flushing plan consideration. So when they're developing that plan, they want to see, have them assess those runoffs and where they might need to apply dechlorination requirements in order to not contaminate those bodies of water. So it's not super often, but it may happen in your community depending on where your systems are in proximity to those kinds of resources. As far as the post-assessment review, it's pretty important because if the model is predicting certain flows and pressures at certain areas and you're not seeing that, it could mean one of two things. One, that the asset information you inform the model with is incorrect. So there may be a segment of pipe or a dead end somewhere that you didn't know about or whatever. Or the other issue, it might be that there's a blockage, for example, where you're not achieving the flows that the model expects. So it's a nice way to expose, like a preliminary blood test would in a human being to tell you whether you should do further testing. Well, this is a good way to understand, like, hey, the model's wrong, why is it wrong? And it could be an underlying issue somewhere, either with the data or with the system.
That's wonderful. Thank you for highlighting different areas that you may want some post-assessment review for your engineering firms. Okay, wonderful. So now that we've looked at the groundwork to creating, assessing your assets, surveying them, and creating that plan, step 4 is all about the execution of that plan. So it's important to find a method or a process that works really well for you and your organization to be able to deploy this plan. In this section specifically, we'll talk about some of the different resources and tools that you leverage to do this, different communications, different equipment, and different technology that you would want to leverage to record geospatially your assets and have those processes in place. Dan, can you take our guests through a journey of what that might look like executing the plan?
Yeah, of course. Yeah, so Mark and I will tag team this one. I think, look, so if we recall, like the end of the last step is we have this output where we have our zones and sequences. I think the first step that's really important to select is how you're actually going to manage the sequence of work. So, you got your crews going out and they need to actually perform this. So again, this is an area where you either want to think about doing this kind of, with a platform that is mobily enabled to help dispatch crews, or, I won't disparage the pen and paper way either. I mean, I think, it depends on what works for you, but the point here is that this is a geospatial activity. So you got people who are working on multiple assets out in the field that need to coordinate with one another, and how you implement the plan for that, needs to be carefully orchestrated. So when selecting, if you do choose to select an asset management program, again, this isn't a sales pitch, but this is, more practically when you're thinking about using an asset management platform for UDF, you do need to consider how that accommodates sequenced activities and capturing, at the minimum, what's open and what's closed and what needs to be done next in that sequence. If you do it the pen and paper way, it's a similar exercise. You need to have a really clear sense of, on a map, what's next for the crews and how are they managing, the information flow across the crew to determine what's next. Secondly, just on a more practical, non-technology related note, it's definitely important to define roles and responsibilities. So I don't want to spend a ton of time on this point, but on typically your crew lead, you want to consider what their role is versus the rest of the crew. So who's sort of owning that daily work schedule, the list of high priority notifications and calls if they need to happen, operating the primary flushing hydrant and performing tests, whereas the supporting cast is doing some of those ancillary tasks, turning valves and assisting in traffic control, any one of those sort of secondary activities. Just a couple, and then just a couple, again, like golden rules here. A good thing to do when flushing is just to monitor downstream. So have a way of understanding what downstream pressure starts to look like. So you should expect downstream pressure to drop, but keeping a close eye on that level dropping to levels that would be unexpected or could create sort of a negative pressure event would be something you want to do. And then secondly, I think Mark alluded to this earlier, but just in terms of how you want to, as you approach each sequence, you want to be prepared really to be taking 2 samples, both on turbidity and chlorine residual, with your turbidity set to around 1 NTU, or depending on the goal of your program. We also, just on the left-hand side of this screen, we have a little bit, this is, if you weren't using an asset management system, this is an illustrative way of thinking of a way to be scheduling and collecting data on your assets. So Mark, do you want to talk about that template briefly?
Sure. I'll speak to 2 things. I'll do that, and I also give you a couple of field tips I learned during this part of the work. But on the left lower there, that's just a screenshot of an Excel workbook we'll provide you guys, so that when you're developing your plan, you'll want to prescribe the zones and the sequence steps in the spreadsheet if you're not using a system, electronic or computer system or asset management platform to help you through managing this. You would do it manually in a sheet like this. And basically what this does is that this sheet is married to a map. So what you'd want to do is print out a map and that shows the segments being flushed, the valves being exercised, and the hydrant being flushed, or hydrants that are required to be flushed to get that velocity through that main. And get that map. A cool tip, there's 3 tips I'll share here. You have this sheet down below for that step in the sequence, which tells you which valves to exercise, which hydrant to flush, and what the target flow rate would be. That homework was done already. And you basically have those additional fields in there that define what you're going to collect. So that's the turbidity and chlorine measurements 2 minutes in, and at the end, you're going to define your start time and your end time, so you know how much water we wasted and use that later on. We want to measure the downstream pressure. We also want to put comments in. You want to be able to say, what was the nature of the color of the water? Was it brown? Brown? Was it rust? Just some additional metadata there. But basically, you just filled out this sheet and you'll follow the sequence. And the sequence should walk you through, like, open these valves, close these valves, open these valves, close these valves, and walk you through that for that sequence area. Some of the cool tips that I've heard of here is, one is installing knuckle valves on that downstream measure pressure test. So install a knuckle valve, open up the hydrant, and the knuckle valve set up to pressure release at system pressure. So, if you experience any type of water hammer or anything through this flushing event, that will relieve any overpressurization events that might cause a main break. And so, not that main breaks are super, risk, they are a risk, and that's another way to mitigate that. But another cool tip is to get a 3-ring binder and get the map and open up the binder top to bottom, where you have a sheet on the top and the bottom, where the bottom sheet is this worksheet and the top sheet is the map. And you can kind of flip through each one as you go to execute this work. So those are a couple of tips there. And this worksheet we're going to provide as part of that toolkit we're going to give you later.
Wonderful. Awesome. Also, in part of executing our UDF plans, it's not only about going out and facilitating the work and getting out and flushing the distribution system, there's also some preparation work that has to take place in order to be able to deploy and execute your UDF plan. Some of those items that you'll want to consider is communication, how you're going to be communicating with your customers, and also deciding what the best equipment to use is. So I'm actually going to hand the presentation over to Derek to take us from Unilink to take us through how to best communicate with our customers when you're planning to execute your UDF.
Okay, thanks, Amber. If you could bring up the first slide there. So we see, you heard a lot of good ideas on how to create your plan and how to get ready to execute it. It's always a good idea before you execute your flushing plan to let your customers know what to expect. And why do you want to do that? Because the first time that you do it, of course, you're going to generate complaints, and we want to limit the number of complaints we get. We want to limit those number of phone calls that come into the office and so forth. It also builds trust with your customers. It shows them that you're trying to be actively communicating with them, be transparent with them, and so forth, and it avoids any negative publicity for the municipality. So how do you communicate with your customers? Well, there's quite a bit of ways you can do that. Traditionally, you would send a letter out to your customers. You may post something on their, print a letter out and post it on their property. There's some better ways these days to do that. Electronically, you can make voice phone calls to your customers. Of course, you can send text and emails. There's your website, posting information on your website. And of course, in today's world, social media is a good way to do it. And you can see with social media, you have your Facebooks and Twitters and things like that. Very low cost, if any, or no cost, as opposed to printing out and mailing letters or actually physically walking out and posting letters on properties. So there's some advantages of doing that as well. Who should you notify? Well, a lot of times you don't have good information in your utility billing system or in your customer information system on making phone calls or sending text messages out. So you sort of rely on addresses and things like that. And of course, you don't want to notify everybody when you're going to do this. You heard Amber and Dan talk about setting up different zones to do your flushing. You don't want to notify everybody in your community if you're only flushing a certain zone today. So another good idea to have would be to have your database of your customers, make sure you know what zones those customers are in. So you're only notifying customers that are going to be affected today. And as you can see from the last pro tip down at the bottom of that previous screen, it said just make sure that the appropriate person at each facility is notified. Again, a lot of times in your utility billing system, you may have contact information for somebody in accounts payable or somebody in a sales environment or something. Make sure that the appropriate person at that facility, especially on a commercial property, the facility manager is notified, that they're going to experience some low water pressure today or some discoloration in their water and so forth. And then sort of the last thing on the communicating with your customers, as I sort of alluded to, it's hard to communicate with your customers if you don't have good contact information. So make sure that your utility billing or your customer information system has good contact data. And with this contact data, you need to distinguish, I mentioned earlier also, where your customers are located by zones, by districts, by GIS coordinates, things like that, so that you can specifically notify certain groups of customers as opposed to all your customers. It's always a good thing to have your utility bill and customer information system integrated with your asset management program so that you can go into your asset management program and when you're going to do a hydrant flushing, pick a zone so that your zone can communicate back to your utility billing and customer information system on who the customers are in that zone. So again, a way for you to easily collect updated information from your customers. I just actually got a message from one of our customers today where they were trying to get good phone numbers for all of their customers. They service about 25,000 water customers, and they only have about half of those phone numbers for half of those customers. So they put some information on their website, on social media, trying to get their customers to provide them with good phone numbers so that they can contact them. So those are some easy ways that you can communicate with your customer and some general ideas on customer communication.
Wonderful, Derek. Thank you so much. So once you've looked at communicating your customers and you have your, UDF plan in place to execute, one of the items that you might want to take into consideration is the different type of equipment that you're using. And Michael Anderson from the Hose Monster Company is actually going to take us through what some of these considerations might look like. Michael.
By Dan and Mark.
Michael.
Hello.
Hi, we can hear you.
Can we hear me now?
Yes.
Yes, we got you.
Yes.
Apologize for that, a little delay there. So as I started to say, a lot of great technical information. If you wanted to kind of swing back around and just support all of that like any system, preventive maintenance is so critical. And I see as a manufacturer of test equipment that is used in helping do some of this type of work, how little effort is made into going and doing unidirectional flushing and how important it is for the system. Whereas even in my own community here in Illinois, that twice a year they come out, they post signs, and someone comes out and opens up a hydrant and flows it till it's clean. And maybe 20, 30 seconds, and they close it up and move on. So the critical point I'd like to make is organizing formally a good unidirectional flushing program. And how do we do that? One of the key points we talked about earlier in that velocity calculator is a feet per second or a gallon per minute flow rate that we need to achieve in order to get that scouring rate. A lot of different equipment that can do that and measure that. Some of the things that you'll want to consider while you're reviewing equipment to purchase, if you don't already have it, things such as the hydrant port size. There are some communities here in the United States that only have 2.5-inch hydrant ports to them. Others only have 4-inch hydrant ports to them. You'll need to know that to make sure you select the right flow device to it. Thread specifications on the hydrants. There are many different thread specifications across the country, across Canada as well, including the speed fitting known as storts. And so we'll want to know, how do we connect our test equipment to the hydrants in order to do this flushing? We need to have the right connections, because when you get out to do the work, without the right connection, you can't do it. How large of a main are we going to be flushing, or each lines? Do we know, is it a 2-inch diameter pipe, or is it a 10-inch? So again, depending on the size and length of that pipe, we'll need to know what equipment to connect to that. Again, we talked earlier about that velocity calculator and the flushing and scouring rates. Again, commonly accepted is anywhere between 3 and 6 feet per second. Again, that's existing systems. In a slide we'll run through here in a second. Fire protection system piping, the NFPA 24 tells us that we need to reach to 10 feet per second. So a much more stronger flush rate, but again, depending on the need, existing systems, again, not that big of a requirement. Are there any ancillary tests that need to be done while we're doing this? We mentioned this earlier as well, blend into our flushing design, our flushing tests. Again, can we collect fire flow test results that we can use to improve or upgrade our hydraulic modeling? Is our community going through an ISO review? Again, fire flow test data is required for part of that. Again, types of flushing. If you're just doing some conventional flushing, some people are not that concerned about velocity rates. And so again, there's alternative equipment to purchase to just conventionally flush, or if we're doing a solid unidirectional flushing, we're going to want to know how many gallons per minute we're flowing so that we can achieve those scouring rates. And then again, to environmental concerns, any state or local or EPA requirements in terms of dechlorination that was mentioned earlier. If you are, on the West Coast, California, Oregon, the state of Washington, Colorado, Ohio, are a number of states that do monitor or discharge water. The EPA is very attuned to what's going on out there. And so we'll have to make sure that if in fact that we are required to do that during our flushing program, that we have the right equipment. Equipment anywhere from a sock or a blanket that has tablets to them, or again, further information that we have dechlorinating equipment as well. This next slide here, we can see where, again, select the right equipment for the job. Again, we have small diameter flow kits and flushing kits, and we have large diameter flushing kits. Key point to these, again, is water management. Depending on how large your length of pipe you're scouring is, you could be running tens of thousands of gallons through it over time. How is that water managed? By using some equipment such as ours, we're able to discharge that water without too much interruption into traffic flows, and aim that water to the storm sewers. And again, because water is so erosive, we do encourage the use of diffusers such as this, putting tarps down as well to minimize yard damage, because of course that typically is one of the #1 complaints about the work that's going on. Besides the dirty water, my front yard's now been destroyed and the mulch is no longer here. So that last slide I have up there, again, as I stated earlier, again, underground piping that's brought into a building for fire protection purposes. We're looking at a 10 feet per second, excuse me, discharge rate, and you can see some of those numbers are quite large. A 10-inch pipe, you're flowing 2,400 gallons a minute, and again, multiply that by a 20-minute cycle, that's a lot of water. So again, having the right equipment, being able to measure those flow rates, I think will lend to a solid unidirectional flushing program.
Thank you, Michael. Right. Now that we've made it through the execution of the plan, like every project, it's always good to go back and assess how it went. And this step 5 is taking a look at the plan that you put in place, assessing the data, and refining those plans. What this means here is we want to take a look at any discrepancies that might have occurred within the UDF plan, either from the engineer or any barriers that you might have found in the distribution system. I know Mark had kind of talked a little bit about what this may look like in step 3. Is there any other considerations that should be taken here, Mark?
No, I think it pretty much covers it. Like feeding back the data to the engineer or whoever authored the model is important. Like I said, it could be an early indication of some other issue. But establishing those KPIs, I think that's important. Like understanding, before and after, and as you execute this program year over year or every other year, however you decide to implement it, defining those KPIs and monitoring how they improve over time, and things such as customer complaints, turbidity, chlorine residual retention, you name it, any of those KPIs around distribution water quality, you should see an improvement in those numbers. So it's a good idea to benchmark at the beginning, and then over the years, kind of track that so you can show how the program is affecting those.
Thank you. And that actually brings us to our wrap up for the session today. So what we do want to cover is that we are here as a resource for you. We've taken you through the why UDF, and I'm actually going to look to pass this over to Catherine to kind of wrap us up for today and take us into a question and answer session. But as we wrap up today, we did take you through the why UDF is important. We've also covered several different resources on that can be leveraged when creating your UDF plan, from technology resources to communication to equipment. We'll also provide you with a toolkit following our call today, in hopes that this will help you start your journey or continue your journey through UDF. And in addition to this skills theory, we'll also be deploying other skills theory sessions. So I'm going to go ahead and hand it over to Catherine for next steps and questions.
Wonderful. Thank you so much, Amber. Yes, everyone, thank you so much for participating today. It looks, based on what I've received, that we've actually answered most of the questions. But as Amber mentioned, we're here as a resource, as are our partners at MuniLink and HoseMonster. We would love to be able to assist you in your UDF programs, provide you with tips, tricks, and even solutions to help you create a more effective program. But I think the last thing that we're going to cover before we wrap up in about 4 minutes is we promised that we would be sending you home with some really tangible takeaways. So I'd love, Dan, I know we've covered that a little bit, but let's talk about the tools that we're going to be emailing to all of our participants.
Yeah, absolutely. Again, first, really appreciate everyone showing up. As our first skill series, this is it's actually a quite impressive turnout, and I really hope that this is something that you guys print out and look at as a resource, forever. So if we've done that, we've done our job. As far as the tools, so we will be following up. The best way to share this is we'll be sending a zip file to the participants in the meeting. And the content here is as follows. So we have this UDF checklist. This is going to be, as I said, like the summary of the activities by phase. And that will be a helpful way, just, again, for you to go back to and say, these are the things that we know we need to get going in order to get started. In terms of the second one, we got an asset management survey workbook. So if you recall, that was the slide that Mark was speaking to. When you're going out and doing that survey work ahead of time before you actually start implementing, where you're collecting that asset metadata and you are ensuring that things are working, and if they don't, you need to get a plan in place to fix them. We're equipping you. Again, this is outside of our technology. Our technology can certainly help you do this in a more automated fashion, but just to get started, if you aren't a utility cloud user, this is an Excel workbook that illustrates conceptually how you could do this and is a starting point. The velocity calculator, that was, that's simply a reference table, and will provide a way for you to calculate your velocities, again, through just an Excel template, so we can provide you guys with something immediately. Communications template. So this would be something as simple as that you could use as a hanger, like a door hanger, or you could conceptually put this into some sort of electronic communication. But the typical sort of Q&A and explanation of what's going on and how it impacts your customers. And then finally, your manual flushing worksheet. Again, this is something that would typically be handled through our technology, but again, just to share value immediately. As you're going through flushing, this is a toolkit that can enable you to sort of equip your crews to manage the work and collect the metadata as you're out there in the field. So we'll be following up with those. Again, just really appreciate everyone showing up here, and across all of us, we genuinely hope that this brings a lot of value to you guys. Again, we're here as a resource, and if you guys have any questions about how to get started, no matter where you are in your journey, we want to be a resource. We collectively, everyone who's presented on this call. So again, thank you. Really appreciate your time, and we look forward to helping you more.
Wonderful. Have a great day, everyone. We will be sending out a survey and would love to get your feedback on this content. Thank you for spending the last hour with us. We appreciate you so much. We hope you have a great day.
Take care. Stay safe, guys.